Hey, what's up, guys? This is Chung, and today another Codeforces problem, A and B and interesting substrings. So there are like a bunch of like descriptions here, but in summary, to summarize, what it's saying is that you're given like a list of numbers representing uh, which have which has like 26 elements, and each number representing the score for each of the lower letter English letters from A to Z. And then next one, you're given like a string. And your goal is to find the total number of substrings and which who is satisfying two conditions. The first one is the starting and the ending character is the same. And the second one is what's remaining in the middle, the total score should be 0. Yeah, and that's the basic idea. And here it's just using like A and B trying to explain these things to you. So yeah, and that's the problem. And to solve this problem, since we only have like 26 English letters in total, I mean, a naive approach is not a naive or normal approach is that we have to find the same letters, right? First, let's say we have A here, and then we have a bunch of some characters right in the middle. We have another A here, right? And then we have some other characters A and then another one, something like this. So which means that we need to have like a map, right? A map that's the maintaining the index for all the indexes for the same letters. For example, we have A here, then we have 0, 4, 8, 12. And since we have those kind of the indexes, all we need to check out is that what is the remaining the total scores right in the middle, right? And the common way to do it is use a prefix sum. So now the problems comes down to what? So it's very similar to another very classic problem, which is the find the total number of subarrays whose sum is equal to k. And for this problem, the k equals to 0. And the way we're solving that problem is that we use a dynamic programming. Basically, we're using a DP to store the running sum, right, of each of the location here. And every time when we have like uh, a new index here, we get the running sum, right? We get the running sum of the, let's say if the running sum at this location is it's 20, and then we just need to find the target, right? So and since we need to find if there's any substrings, right, who has the sum equals to 0, that's why we need to find the target pre-sum, which in this case is 20 minus 0 is also 20. So that's why it means that we just need to find out if there's like 20 has appeared before. If it did appear before, and then we just need to accumulate the count for this pre-sum that has appeared before, and that's going to be the new substring we have like we need to accumulate. For example, this one, right? So let's say this one is the total is 0, and this one is also 0. And so when we are at like this one, like the second index here, we need to since we need to calculate the pre-sum with right in the middle. That's why we have a pre-sum Presum is what gonna be the I minus one, since we are going to use the presum at this location, right? And the target is also the same as the current presum is, which is let's say the presum for this part is 7, right? And that's why we are also looking for 7, because if we have a 7 somewhere here, let's say if the ace look if at this location the presum is also 7, then we know that okay, so the middle part is 0, and we just keep updating the frequencies for a certain presum, right? And then we just use that to calculate the result. Okay, so to do that, right, first we need to populate the presum, right? For this 26, we need to populate the presum for this string by using the scores for each of the letters, and then we just loop through each of the characters, and then we just accumulate the substrings for A, B, C, until Z separately, and then we will have our final answer. Okay, cool. So to start the coding here, right? I mean what's the constraints here? We have 10 to the power of 5. Okay, so we have 10 to the power of 5. That's the length of that's why we only need the string here. So we need to like initiate that. And second one is we need the n, right? So and we have a n equals uh, n, and then we also need like a number array to host the strings, or yeah, actually we don't need this one. So all we need is a presum. So first I'm going to initiate the score for each of the character, which has the length of 26, and then the second one is the string s, right? And then we'll read the score first, 0, 26, and then I plus plus, and we just read read this one. And second one's the string, right? So we read the string, and mm, now we need a presum, right? So for the presum, I'm going to use like an unordered map, right? With the total LL, right? That's gonna be the presum. And so at the beginning, right, the presum, we need to like the insert. I'm going to insert the -1, 0 to it so that we can handle the 0 index case. And yeah, and we also need like the vector, the list of vector to store the position for each of the character. That's why we have a length of 26, and each element of this array is also another vector who will store the index for this letter, and then we can loop through the string, right? So I smaller than we have s dot size, I think, yeah. Then I plus plus. So first, the presum, right? So the presum I equals to the presum I minus 1, right? Plus the score for the current character, which is the x dot si minus a, right? since we're using the index trying to find the score. And to get the index, we just do this. And also we need to populate the index, right? To add the index to this vector. So and we have this one, yeah. Then a push back I. So now we have everything we need, and the only thing left is just to define like an answer, right? Equals to 0. And then we just need to loop through all the character from 26 characters, right? And then C is 26, C++. And yeah, so we need a DP, right? I'm going to also use an unordered map since it's a dictionary, right? It's going to be L, 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 L. It's going to be a DP. So for int I in from 0 to position C dot size, right? I plus plus. So here we are looping through the each of the characters, and then from this position C dot side, we can get the we're enumerating all the index for this current character, right? And then we have the index, and for the current index, that's going to be the position dot C dot I, right? That's going to be the current index. And the target, so we need a target, right? So the target is what? Target is is a pre-sum of the index -1 and -0, which is actually the same as the prefix index. So again, so the index -1 is because let's say we have a, right? And we're at this location. That's the I. But since we're trying to calculate the pre-sum in between, that's why we have the pre-sum has to start from here, which is the I -1. Right? And then now we have the answer plus the DP, right? The DP of the pre-sum, uh, the target. Yeah, and then in the end, we just update this DP, pre-sum dot index, right? And then plus plus. And since we are in the for loop, in the end, I'm going to clear this DP so that it can be used next time. And then in the end, I just count output. Yeah. So a little bit more explanation about this part and why this works. So this is because let's say we have a pre-sum here, so that's the where we get our target, right? It's gonna be the pre-sum index -1. This is the place, and we're looking for the same pre-sum before, since we are only looping through the current characters, which means that if we have another same we have seen this same pre-sum before, it must means that there's like another a somewhere here. Let's say we have a pre-sum equals 12 here. If we have seen like a DP, the same pre-sum in the DP, it means that we have seen an A before, right? And we have another pre-sum right here. And that's why the 12 minus 12 equals 0, which means that here we have find another substring who has satisfied the both of the conditions. And this part is just accumulating, right? Because if we have another one A here, and we have let's say here we also have a 12, and we have seen, okay, so by having the second one. So how many new substrings we're adding here? We're adding like actually two. So why is two? So the first one is this one, right? Is this one, and the second one is this one. That's why we can accumulate the pre-sum uh, frequencies and then use it to calculate the uh, the future substring. Yeah. So and let's try to run the some test case. Okay. Okay, that's that. And if I copy this one, so that's two. Yeah. And how about this one? Yeah, if I copy this one and then it's also two. Okay. Yep, I think it works. So and so for the time space complexity, right? I mean, I think it's pretty straightforward since we only have like several single loop for uh, loop here. So that's going to be a O of n, right? So here's O of n, and here the outer loop is 26, which is like the constant. That's why we only uh, care about the inner loop, which is also O of n, right? So the time complexity and the space complexity they're both O of n. Yeah, I think that's it for this problem. You know, just to recap real quick. I mean, so this one it's another like a little bit of variation of the of getting the total subarrays uh, to have the sum equals to k. And for this one, we have to uh, process those answers letter by letter, since we need to find the substrings has the same start and end letters, and that's why we group those letters into the string into different letters, and then we just process the letter individually. And when we process the letters individually, we use the DP concept to calculate the final answer. Cool. I think that's it. Thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.